Hi, in this video I will be covering a step-by-step casting procedure. So let's see here. So the first step is that first a bottom board is placed on a molding platform or on the floor. Actually the floor should be even surface. We need a even surface, horizontal surface. Then as we know, in the molding box there are two parts, one is drag part and another one is cope part. So first of all we will place the drag part on the bottom board, which is kept upside down. It should be kept upside down. So you can see here in this figure that this provision is given for pin. So it says that this is the drag part and it is inverted. Now inside the drag part we will put the drag part of pattern. So pattern has two parts. In case of two-piece pattern there are two parts, but sometimes there is a single piece pattern in which there will be only drag part. So here we can see that this is the drag part of the pattern, so that is placed inside the drag on bottom board, and here it is written there should be enough clearance between the pattern and the walls of the flask, which should be of the order of 50 to 100 mm. Now after putting the pattern, the next step is to put the facing sand. Facing sand is actually dry sand which is sprinkled all over the board. Facing sand directly faces the molten metal, so that's why its name is facing sand. After that, actually it provides a non-sticky layer so that the pattern should not stick with the molding sand. So after facing sand, the molding sand is provided all over the drag up to a thickness of 30 to 50 mm. So molding sand will be freshly prepared. It should not be used sands. Okay. After that, once that layer of 30 to 50 mm of molding sand is prepared, then another sand which is known as backing sand is completely filled inside the drag. So backing sand, actually because it is backing the molding sand, it is known as backing sand, and it is generally the used molding sand. Previously in previous castings, the molding sand which are used, that is used as a backing sand. So now after putting the backing sand inside the drag, it is uniformly rammed with the help of rammer. So ramming is very important in case of molding. If it is done too hard, then it will be very difficult for the gases to escape from the molding sand. But if it is rammed too loose, then there is a chance that it will be breaking easily. It will not have enough strength. So we can see here that there are rammers. This is the rammer which is used for ramming purpose. So it is having two parts. The one which is having the shape V shape is used for ramming the corner parts, and the round shape is used for ramming the central part of the drag or cope. Next, Once the complete ramming is done, then excess sand is removed with the help of a flat bar, which is known as strike of bar. So this strike of bar is used to make the plane, to make the surface of the sand plane. Now, so we can see here, this is the strike of bar, which is made up of either wood or iron. Once it is a strike off, then what we do, we use a vent wire and we provide venting inside the molding sand. So what we do in venting basically is we provide thin holes everywhere inside the molding sand. So these holes are to facilitate the removal of gases during the molten metal when it solidifies, when it is very when the temperature of the molten metal is very high. That time the gases which is coming out should easily escape out from the molding box. If it is restricted, then there is a chance that the gases will be confined inside the casting, that will create different kinds of defects like blowholes. So what is blowhole is basically, we can understand from here. Let's suppose there is, this one is the casting which we have prepared, and the gases are entrapped inside. So these are the blowholes. So this, the problem with this is it reduces the strength of the casting. Next, once this is the vent rod, with the help of that venting is done. Actually it is a thin spiked steel rod or wire having a pointed edge at one end. So these holes are known as vent holes, which allows the escape of steam and different kinds of gases during pouring and during solidification of molten metal. Next step is, the fifth step is, once this venting is completed, after that the drag part, because it was kept inverted, now it is rolled over in a proper position. Now what will happen, the bottom part will be exposed, which was having pattern exposed, like you can see here in the previous diagram. Like here we can see that this one is kept, so whatever sand is put here, that will be covering this part. So the bottom part, this one, this will be free. So whenever you will invert the drag, then it will look like this. So this plain portion will be exposed. After that, since the around the pattern, the edges of the sand may have some distortion, so that is repaired with the help of slick. After that, we place the cope over the drag, and then the cope part of the pattern. So I told, in single piece pattern the cope part is not there, only drag part is there. But in case of two piece pattern, there are cope also and drag also. So first of all, the drag is kept in the drag drag part is kept, drag part of the pattern is kept inside drag, and now the cope is kept, and inside that cope part is kept. So we can see here the cope is placed with the help of a locating pin or aligning pin. Okay, once it is done, then you can see here in the diagram the the cope part of two-piece pattern. Here we are using two-piece pattern. See, this is the first part which is kept in the drag, and the cope part is kept in the cope, and both are aligned. So they are aligned with the help of dowel pin. Here we can see this is a two-piece pattern. So one half among them, which one is the drag part and which one is cope part? Can we identify? Yes, this one which is having completely flat surface is drag part, and which is having dowel pin is cope part. If we use cope part in the drag, then what will happen? Because it is not having flat surface, it cannot be kept on the plain bottom board. It cannot be kept on the bottom board because it is not having any flat surface. Clear? Next, once the drag part is kept and the cope part is kept, after that we place the dry parting sand, because we put the parting sand here, so that after that we will be putting the molding sand. You have that in the cope part. This one is the cope, so this will be filled with the molding sand, but before that we put the parting sand. Here we sprinkle the parting sand over it. Why this parting sand is a sprinkle? So that the cope and drag should not stick together. If they adhere, then there is a problem that the sand from one part will go in the other part, and there is a chance that my molding will distort, or it will have some kind of cavity. This kind of cavity may appear, so that is not desirable, and that's why this is completely sprinkled with dry parting sand. After putting the dry parting sand, we put a sprue pin. So this one is a sprue pin. So this sprue pin is used for making the sprue passes. Sprue, what is a sprue? We have understood that through a sprue the molten metal is poured inside, so that it will enter into the cavity which is present here. When you will remove this pattern from the molding sand, then there will be a cavity created. So the molten metal is poured through this sprue. The molten metal passes. So for making this a sprue, there is a sprue pin which is required, and it should be placed at a small distance of about 50 mm from the pattern. After that, if riser is required, then we put a riser pin, okay, at a appropriate place wherever it is to be kept. Once this is done, then the molding sand is put over it inside the cope part, and after that we go for backing sand, and then we go for ramming, as we have done in drag part. Same things we do in cope part, and then a scrap we use the strike of bar, and we scrap the excess sand. After that, with the help of bent holes, we create with the help of vent wire, we create vent holes in cope also. So here we can see that this is the feeder. Actually, this is also known as feeder or riser. Okay, so feeder and riser. So here this is the sprue pin. So a sprue pin, directly molten metal is not poured inside the sprue, rather it is poured first in the pouring basin. So here we have to cut a pouring basin, and this is the riser. Once this ramming is completed, the whole cope part is completed, then a sprue pin and riser pin are taken out from the molding flask, and pouring basin is cut, and then we can cut the gate also. So below the sprue, here is the sprue, from there molten metal will come, so it will fall and it will go through runner. This is, here is the runner and here is the gate. So this one is gate and here is the runner. So runner is, I have told in the last class, runner is a horizontal passage through which molten metal enters into the mold cavity. A sprue is a, this is a sprue which is a vertical passage. A sprue is a vertical passage, runner is a horizontal passage. So from the, when the metal is passing through a sprue, it enters into runner, and through a runner it goes into mold cavity with, through a passage which is through a gate which is known as gate or ingate. So these all are cut by the help of gate cutter. So this instrument is known as gate cutter. Now what we have to do, we have to remove all the setup is ready. Now we have to remove all any kind of loose sands through with the help of bellow, and the cope and drag part, from here we need to remove the pattern so that we will see the cavity. So these patterns are taken out with the help of draw spike. Okay, so we can see in this diagram that how draw a spike is put into the pattern, and the pattern is taken out from the molding sand. Once it is taken out, then both drag and cope part is put over another. This is the drag part, which is the lower molding flask, and this is the upper molding flask, which is cope, and both are aligned with a pin, locating pin. And we can see the riser is this is the sprue and this is the riser, which are cut here. These are the vents. So from the outside it will look like this. Once it is aligned, then what we do, we melt the metal and it is poured inside the pouring basin, which passes through the sprue, and the notation is wrong here. This is not runner, it is a sprue, and after that it passes through runner. This is horizontal passage is runner and enters into the mold cavity. After solidification, we break the mold and we take out the casting. So this is the solidified metal in the form of product, having two extensions. One extension is this one, which is riser extension, which is not desirable actually. So we have to cut it from here, remove it from the product. And this is the sprue part and runner part. So this also should be cut and removed from here. Okay, now some of the other instruments which we use, like bellows. So what is bellow? Actually bellow is a hand operated leather made device. Actually we use motor operated bellows also, but here we are talking about the hand operated bellows, which provides compressed air jet to blow or pump air when operated. It is used to blow away the loose or unwanted sand from the surfaces of mold cavities. Here is the gate cutter. We can see the cutting of gate. Gate cutter is a small shaped piece of sheet metal commonly used to cut runners and feeding gates for connecting screw holes with the mold cavity. These are the draw spikes. With the help of draw spikes, what we have done, we have taken out the patterns. So draw spike is a tapered steel rod having a loop or ring at its one end. We have the ring and a sharp point at the other. Okay, so it may have sharp point, it may have screw thread also at the end. So here there is a screw thread. So in case of metallic pattern, when there is a metal pattern, then the draw spike cannot insert inside. So let's suppose this is the pattern, okay, and it is made up of wood. Then if it is draw spike is having pointed end, then it can easily insert inside if we tap it, and then we can take it out. The pattern can be taken out. But in case of metallic pattern, when it is made up of metal, you cannot insert the draw spike inside the wooden pattern, inside the metal pattern. In that case, in metal pattern there is a provision that it have a hole having thread, and the draw spike is also having thread. So draw spike is tightened inside the hole which is inside the metal pattern, and once it is tight, then we take out the pattern. So the draw spike with threads is used in case of metallic pattern. A sprue pin. So a sprue pin is basically a tapered rod which is made up of wood or sometimes iron, which is placed or pushed in the cope to join mold cavity while the molding sand in the cope is being rammed. Later it is withdrawn from the cope through a vertical hole, producing a vertical hole in moldation called a sprue, through which the molten metal is poured into the mold using cutting system. Another instrument is hand riddle, which is used for screening the sand. We require hand riddle, which consists of a screen of a standard circular wire mesh. So these are the mesh. This is one type of mesh. This one is finer mesh. This is little coarser, and this is much coarser. So it is generally used for cleaning the sand for removing foreign materials. Any kind of foreign materials like nails, short metals, splinters of wood are there, it should be removed. Even power operated riddles are available for riddling large volume of sand. Here is a shovel, which is a steel pan fitted with a long wooden handle. It is used in mixing, tempering and conditioning of ordinary sand by hand. Obviously the sand will be a large quantity foundry sand, and that is to be handled with the help of shovel. It is also used for moving and transforming the molding sand to the container and molding box or flask. So this is for today. Thank you.